Okay, you have done the fixing, and everybody has gloves and goggles. Okay, what we're going to be doing here is that we are going to find out exactly how much oxygen is in the stream water. Do you think that there should be a lot of oxygen, or do you think there won't be much? What's your prediction? Okay, we have snow up in the mountains. The snow is melting and it's getting down here. You have water in the stream. You have fixed the oxygen by adding all the chemicals from over here with Katie. And what we're going to be measuring now is the amount of oxygen that is actually in our sample. And the oxygen has been replaced in the sample by the iodine. Can you see the color here? Okay, so the first thing we're going to do is we're going to put in 20 milliliters of our sample solution into this jar. So, Angela, would you like to do that? Yeah, and to do that, you need to have your goggles on. Okay.
No, I think I should take this off.
Yeah. Take the hat off for a second. Okay. So you're going to add it. Can you see the 20 milliliter mark here?
Yeah.
Okay. And I'm going to put my finger here so it doesn't tip over and you can pour it in. You notice I'm wearing gloves in case you spill.
What happens if you do spill? It's toxic. It'll burn you.
And now I'm going to put my glasses on and see if it's right on the number.
What happens if it touches your skin?
If it goes over, we have a pipette. Can you see that it's absolutely perfect? Okay. Can you see it's right on the line? Okay. So the next thing we need to do, save our sample in case we've made a big boo-boo. Okay. So the next thing we're going to add is starch indicator solution, and so Jenna, you're going to do that. How many drops did you add at the last station?
8.
Okay. So you can add your 8 drops. Ta-da. Okay.
The evil witch.
And can you see it's not mixed?
Yeah.
So you mix it, and you're going to do all your mixing by gently swirling your sample in the bottle. So to find out how much oxygen, we've got to use this chemical, sodium thiosulfate. This is the fun part. And for this, everybody's going to need to have goggles on. And one of the things I have to be really careful of here is that we don't have any air bubbles. Can air bubbles measure oxygen, or do we need the chemical? Do we need the thio? And what I want to show you here, can you see the bottom of the syringe? Can you see that little flat disc? And it's on the 0? Yet. Yes, there is. What color is it turning? Purple. And the next color it's going to turn to will be blue, and then after that it's going to go clear. Okay, let's see what's happening.
Oh, that's cool.
Okay, we still have some blue, and I'm going to hold this up to, let's see, where's something good and white. Can you see there's still blue in there? Okay. So this is going to be 1 drop. Because this color change will take place very quickly. Is it clear?
Yeah.
Or is there still a little bit of blue? You tell me. Is there any blue left or is it clear?
It's clear.
Okay. So now we're going to read the number on the syringe. Can everybody see that it's more than 8? Okay, and we have to go down now to see how many parts below the 8. 1, 2, 3. Each one of these is 0.2. What would be 3 times 0.2? 0.6 plus 8 would be 8.6. So that's the number we're going to record. So let's take a look here and see what this means as far as who can live here. Trout can live with 6.5 parts per million. And what was your record?
8.6.
8.6, okay? So everything that's on here can live in with this much dissolved oxygen. And trout need more because they need the cold water to flush over their gills so that they can get enough oxygen to survive. So, do you think this is going to change color when we push the rest of it in here? We've already removed all of the iodine, which is equal to the amount of oxygen that you fixed. So what color should it stay?
Clear.
Clear. You want to prove it, Angela? Push it all in. Did it stay clear? We're way past our end point now, aren't we?
Yep.
Okay, and what do I do to dispose of this? Can anybody tell me?
You put it in the little ground.
Should I throw it on the ground?
Nope.
Should get it over here in our waste disposal bottle. So the next thing we're going to do, and I'm just going to put this here for right now, is I want you to take off your gloves because we're through with the chemicals. Show me that you can do it. Pull it this way and leave it on. Take it with the other glove. Put your hand with the other glove, like this, and now take it off. And this way, no chemicals are going to get on your hands. And here we go with our bag. Okay, the last thing that we're going to do, and I'm looking for somebody who wants to do the calculations for percent saturation. Only one volunteer. Turn it on first. So we have 8.6 parts per million as our result. That's how much dissolved oxygen is in the stream, and we're going to multiply it. And since your temperature was taken as 13 degrees Celsius, you're going to multiply that by 9.21. And what number did you get?
79.206.
Let's see. Okay, and we're going to round that off. And since 2 is less than 5, it's 79% saturation. And that's what you're going to look at. Okay. Now what does all of this mean? This one's going to come apart. What we have here in terms of percent saturation is not as much as 90%. It's less, right? 79% would put us where?
Acceptable.
To the acceptable range. Okay, let's see. Who's keeping the data?
Don't.
Okay, I want to see that you got all the information in. You got it in. So basically, 8.6 part per million, 79% saturation. You've done a great job. And the other thing we need to do is, where is your sample bottle? Right here. It's going to go back to Katie. And how do I dispose of it? And the other thing that I need to do is to rinse the bottle.